Hey everyone. Well, I'm honored and grateful to have you with us either live or in the recording. I'd like to introduce myself. My name is Steve Sashihara. I'm the founder and CEO of Princeton Consultants. We are a firm with offices in Princeton and New York City, and we have three AI-related practices. One is we do full optimization models from beginning to end. The second is we'll take models that are either trying to get deployed or have been successfully deployed and help review them and improve them. And thirdly, we work with teams possibly like the ones you're working in right now to help them achieve best practices. Today's talk will be drawing from all three of these practice areas. And I just want to start by saying that I'm often introduced from my book, Optimization Edge, and I want to start by actually giving the real history and credit behind this book. The real genesis of this book, and all the credit goes to Dr. Tom Davenport, and he wrote in 2007 a book called Competing on Analytics. And it was, according to how he wrote about it in his humble preface, a smash bestseller that no one was expecting, and it was quite a high impact. It actually introduced the term analytics into the language. He had largely coined the word, and I just want to start by saying that because it was a brand new word, he had to start by explaining it, and he started with the following illustration here. He said, "Hey, analytics, we're going to be talking about how to do it, why to do it, who's doing it, who's not doing it. Well, let's just start by what it is." And in one picture, here is analytics as 8 increasing levels of techniques, starting at the bottom and working up to the top. So we start with standard reports that we've been doing pre-computer all the way back to um, Roman times. People were generating reports, but as we move up, we get more intelligence into the analytics and more competitive advantage. At the very top of the food chain, he said, the most competitive and highest value is called optimization. And because this was such a fabulous and impactful book, McGraw-Hill was looking around for someone to write on the topic of optimization. And I was very eager to jump into that and do that. So Tom Davenport also got people talking about analytics, who into data science, which I claim is a rebranding of analytics. Not everyone agrees, and wrote this wonderful article called "Data Scientist: The Sexiest Job of the 21st Century." Maybe a little bit of hyperbole there, but still a great read. And certainly now everyone's talking about AI, which I'd like to claim is basically an evolution. In fact, this is the way we see these three terms. We've used the terms analytics, AI, and optimization. We see analytics as, or data science as the examination of data. Artificial intelligence is to automate human intellectual tasks. And optimization is basically a subset of artificial intelligence where we make recommendations. So some amazing artificial intelligence that can create pictures or tell you whether this is a picture of a cat is not optimization, but all optimization is a form of artificial intelligence. So that's how we see the three. By AI optimization, we basically said it has 4 attributes and 5 steps. So let me talk about these 4 attributes because I think it's very relevant to the conversation we're all having today about AI. So we believe that successful AI optimization has to give accurate recommendations, i.e. recommendations that are valid and of high quality. This has got some challenges. There are many different objectives, short-term and long-term. So it is a recommendation optimizing short-term objectives or long-term objectives. How does it blend the two? Sometimes the objectives are hard to or difficult to quantify. And there are different strategies to talk about how to achieve accurate recommendations. Some include, and I'll be talking about this today, running the model in the field to validate data and assumptions. Secondly, successful optimization provides clear recommendations, unambiguous, precise, and concise. And this can be challenging because a concise and precise answer might not just be what the model is recommending, but why. Also, the mechanics inside the model, and this is something a lot of the large language models are struggling with right now, is it's hard to explain why something is true by just pointing to the interior mechanics of the model. But there are also winning strategies, including avoiding black boxes and other techniques. Thirdly, for this to be working, particularly in the context of end users and businesses, it has to be sufficiently fast. So the overnight runs are something that your parents or grandparents found acceptable, but most business users today want something that has low latency, rapid throughput, and scalable. And clearly, these present challenges as early models which run in fast time slow down as nonlinear factors are added, even with Moore's law chugging away. Also, the introduction of Internet of Things and other data collectors means that the data and transaction volumes keep increasing. So there are multiple winning strategies for this as well, including between times a user is examining an answer, in the background, use spare cycles to continue to improve the search and solutions. And finally, and I think most importantly of these four, the model has to be robust. It has to detect faults and failures, avoid them, and have a low bug count. And I think this is one of the most important problems in modern AI, is that the market conditions change rapidly. And so the training data sets used to train a lot of models, particularly the large language models, may become invalid if the conditions change sufficiently. Also, for all models, LLMs or otherwise, the data can come in late, missing, or be erroneous. And so it's really part of the toolbox to detect and fix data in real time, and also to use techniques such as the mixed integer programs that do not rely on training data sets per se, but actually can try all possible combinations, score them, and come up with a winning answer, regardless of whether the conditions have been seen in historical data or not. But finally, finding an experienced group of optimizers rather than giving this to one person who may not know one technique. So I mentioned there were these four attributes of successful optimization. How do we get there? It's these 5 steps. And I'm going to be talking about this at some length today. I'll walk you quickly through the 5 steps. The first we call the charter, which is as an enterprise endeavor, you pick the right areas of opportunity. Could be department, it could be decision class, it could be geography, it could be a product line, it could be anything that is possible. But basically, you're trying to find what's the right area of opportunity and assembling the correct team. Once you have picked an area, now you take a bunch of candidate decisions that are being made in that area, and you use real data to prove feasibility. And very importantly, you quantify the value of fixing this for the organization. So if we improve the decision process, often in today's world, we're taking a process that is done with very simple rules, maybe people sitting around Excel spreadsheets. If we could bring this into AI optimization, what would be the value to the organization? And then we try in the early win to get this into real production, show a pilot where people are actually using the model to make real decisions and have real impact. We then, based on that, scale it across the entire enterprise and make the use of this new technique the default behavior. That's system and process. So not something that they look at occasionally or look at if they want to, would say, this is the default behavior. This is how the enterprise does this particular area. And finally, what we like to call the harvest. And this is largely from the viewpoint of the AI, OR, the analytics team, that we are allowed and invited to expand the functionality of the project. We get full credit for it. Thank you. You've really had a big impact here. But also, in addition, we are able to transition the support of this model away from the people who built it, and we can start new projects. So that's the full 5-character life cycle. Just to give you a quick deliverable aspect of this, the first is we want to get an executive sponsor and a team. The second, let's figure out what's at stake here. What's the size of the prize, so-called? Third, can we get a production at pilot sites? Fourth, can we get full field installation at, as the default process? And 5, the team is rewarded and expands. So those are the 5 steps of the life cycle. So that's a wonderful world. So part of this talk is to get away from the wonderful world and talk about what really happens in the field. And I think the number one thing that we see a lot of is a chasm forms between the early win step and the scale up. So the early win is the proof of concept is running at some production site, but we'll often see that as the case. But what we don't see is that the organization has been able to or willing to scale this up to run across the entire enterprise. So it creates basically a chasm. This phenomena is not limited to our field. In fact, it's a generic problem in technology. Very famously, a wonderful book called Crossing the Chasm was written that talks about how this chasm appears over and over again in anything technological, a separation between the early adopters and the early majority. To give you an example, the iPhone successfully made it across from early adopters to eliminate the push button phone, and now some high percentage of all adults in America or around the world use something that either is the iPhone or looks like the iPhone. It successfully crossed the chasm. By contrast, one might argue that electric vehicles are in the process of or trying to cross the chasm, but they're still maybe the domain of early adopters and have not yet basically eliminated the internal combustion engine. And this story keeps repeating over and over again. Consider, for example, Apple and the iPhone. Starting 2 weeks from now, they're going to hope to introduce the Vision Pro. And basically, they hope that it is not just a sell to early adopters, tech enthusiasts like yours truly, myself, who is definitely going to buy one of these things. In fact, I put on a pre-order. But the real success for Apple and for others in this field will be, can they get people like my mom to use it rather than just the early adopters? So that chasm between early adopters and early majority, or the scale up, it's not just something that we have to look at ourselves for. It's something that's true of almost in all technology. Academia, which rewards a successful advance, really is generally happy with the early win, but business really needs to see the scale up in the harvest. For business, the benefits only occur at scale. So they only really, unlike academia, which says, hey, you're brilliant, you've advanced the state of the art, here's your PhD, here's your professorship, here's your paper. Business only says, show me the money. And the money only occurs when you can scale it up and get it into production. But since businesses are solving for money, shouldn't that savings be sufficient incentive to scale something up? Like, why aren't companies doing this? I said earlier, I see often over and over again people with very promising projects, but they're stuck in the pilot use, and they have not scaled in production. You go out in the field, and despite people at headquarters saying, hey, we've got this model that can solve this problem in seconds and saves millions, you go out in the field and you see Excel spreadsheets and people sitting around looking at traditional screens, dragging things with the mouse. So if a model exists that can solve this problem, shouldn't the businesses be highly incented to do this? Yes, they should. And so the questions are, why does this chasm exist, and what are some strategies for crossing it? So at a very high level, just as a quick, the reason that the chasm exists at one level is because convincing the early adopters, the people who are going to run out and buy whatever new thing, amazing new thing Elon Musk or Apple produces, people like myself, people like some of you, are different than to convince the mainstream. So the early adopter people are different than the majority people. I want to talk about a strategy for crossing, a successful case study that features a colleague and friend, Mr. Jack Levis, and a colossally important project called the UPS Orion Project. The UPS Orion Project was their name for the project that schedules where every single package truck in the UPS network, every single day, the route it takes. And what Jack did was he was successful in getting this scaled up at UPS. Prior to that, at the beginning of every day, every driver was given a list of their stops, pickups, deliveries, and it was their job, using their head and their experience, to route themselves through those stops. And Jack's mission was to basically put AI optimization into that. The stakes were very, very high for this. Very tiny increments. If you could save 1 mile for each truck across the entire network, it was $50 million a year. If you could save 1 minute or 1 minute of idle time, it was worth millions, thousands. And so they developed this product called Orion that used all the techniques that you might imagine to solve this problem. So Jack and his group developed a custom state-of-the-art optimization model that could both solve the entire US map data set. They could show this doesn't just work in cities or doesn't just work in suburbs. It works across the entire country, which is where UPS serves. And it could significantly improve the major business key performance indicators, improving stops per driver per day. So each driver could do more stops, at the same time reducing miles driven. So a double win. Not only could the drivers handle more loads, but by coming up with the shortest paths, you would actually reduce miles driven. However, Jack found that they could not progress beyond a few pilot tests into full production. So he was facing that chasm. Yes, we have the math done. Yes, we have some early pilots, but no, if you go out in the field and look at how 99.9% of drivers every single day at UPS do their job, they do it the old way. They do not use our model. So Jack took this on as his mission. So here are the 5 lessons from Orion. I'm going to go through them, but I just want to show you them first. Before I jump into them, I just want to say a lot of what causes the chasm is conventional thinking from people like you and me. So I want to come up with 2, I think, impediments that we have, kind of common conventional thinking. Okay. One is what Jack's team had done, and what you often do, and I see a lot, is we think of ourselves as our job is somewhat like an academic, is to create a better mousetrap. And what Jack and his team found is this is an incredibly hard problem to solve. We've read all the literature. We programmed and tested it and found that not one thing worked. We had to actually cobble together a bunch of things. We actually innovated a few things. Possibly we'll be able to publish it. Maybe our corporation wants us to hold it back as a trade secret. But hey, we solved an incredibly difficult problem, and it's worth millions and millions of dollars. It's way better than the current practice. So often those of us in our profession say, my job is to build models. So I am this brilliant person that knows mathematics and knows computer science and knows data science, and that's what I do. And in particular, because I'm concentrating on that, I am not IT, and I don't do field implementations. My job is to create the better mousetrap, and I partner with others to actually get the thing installed and scaled up to the field. And I'd like to claim that that is a common misframing, and it's a common reason why we have failure. Jack, by contrast, basically says, get out of corporate headquarters or wherever you typically work, go out into the field and look for what works and what doesn't. So he basically, his team personally, went out into the field and showed actual maps to actual drivers to show them, here's the route we think you should take. And here's what they found. Oh, lesson number 1, get out there. Lesson number 2, here's what they found. First of all, they found the data that they were using, these map data sets, were terrific data sets. But what the field told them is, your data that you have is worse than what we already know in our heads. For example, they would say, look, your model in going from Walmart to Hampton Inn thinks the best way to do it is to get on the highway, drive down, turn around, and come back. But that's ridiculous, because what we know is drive down to the end of the Walmart parking lot, and there's a small private road. You can just be there in 5 seconds. So, your map, data doesn't know that. That's not my problem. But the solution is terrible. So a solution might have said, oh no, do Walmart and then do Hampton Inn with a different driver on, or later on the day. And they might say, why didn't you just do both stops at the same time the way we would have? And so one little problem like that can wreck the entire schedule. So lesson number 2 is let's use data science to clean the data and fix the logic. See this guy in the upper right hand here? Too many times that's us saying, hey, look, what do you want from me? Garbage in, garbage out. I'm not the data guy. I'm not IT. I didn't create the data sets. My job is to create algorithms. And look, let's face it, garbage in, garbage out. You cannot be that person. You should not be that person. Give you another example. So the original model used shortest path algorithms that we've seen for a long, long time, traveling salesman type algorithms, and so it would create a route like this. You take each stop and you go in this order. What the field told Jack and his team, he said, well, in some cases you can do things like that, but in most cases that's just completely wrong. Firstly, you're not crossing back and forth across the street like that over and over again. And sometimes there's a divided median in the middle, there's oncoming traffic. The real way to do it is you have to go down one side of the street, turn around and come back down the other. It may look like a longer distance, and yes, you have driven more miles, but it's much faster. And we're trying to get additional stops in, not just not just minimize miles. And crossing back and forth over the street, something a beginner might do, is very accident prone. And so we're also trying to solve for safety and other things. So what Jack realized is the fixing both the data and the logic. And I like to say this to everyone listening, it's your job. In fact, your job depends on it. This is not, hey, this is for someone else. My job is create the fastest, coolest algorithm, use the coolest tools. No, your job is to change the field, change the world. And if the data and the logic are problematic, and they almost always are, then a big part of the problem is fixing it. Thirdly, focusing on behavior change. A lot of us feel that what we want to do is build a better mousetrap, and shouldn't everyone just use it? And like I said, the gap appears because the late majority, the scale up, they don't necessarily respond instantly to that's obviously better. I'll just use it. So there's lots of techniques used for behavior change. One of my favorite ways that Jack Levis used to talk about, he said, we go out in the field, we present our stuff, and there's lots of techniques for that. But he said, the week prior, someone else came out and did some other kind of change management program. The week before, someone else. The week before, someone else, and the week after you leave, someone else is going to come out. So he said you have to change the conversation around the way they do their jobs. If you don't change the conversation, you are flavor of the month. So it'll be very polite. You'll get a round of applause. Yeah, this gives a lot to think about. We'll definitely be doing this. And then 2 weeks later, they're on to something else. So you really have to think about how we change the way that the field talks about their jobs and does this to help them do a better job. Can they see themselves using it and achieve what they're trying to achieve? My mom is not trying to impress all her tech friends by using the Vision Pro. She's solving for other things. So can this help her do things that she's solving for? The driver does not get paid anymore if they save 2 miles a day. It looks good on their annual review, but what are they solving for? What are they trying to accomplish? For example, a UPS driver's job is to get all of the packages given to a day delivered. What happens if they can't get all the packages delivered? They look terrible. They feel bad. It goes poorly in the performance review. They might have to work a little overtime. There's lots of problems. So anything that can help them do their job better and faster, that's now talking to them where they live. As Jack says, though, you've got to change the conversation. You can't just give them better mousetrap. You've got to say, hey, what's this thing trying to do that makes sense for you? How is this going to help you do your job better and have a better life? Fourthly, um, measure impact. So yes, Jack's team had done this up in his lab, had presented had written white papers, but now you want to actually measure real, honest to God impact in the field. So at each individual site, what's the impact? And it's always helpful if you have a control, just like any pharmaceutical study. Anything that allows you to have a control group is terrific. So at a UPS site, they would say, let's take half the drivers and have them use the new tool, and half the drivers and they use the status quo. And we'll track as adoption happens how that improves the performance. So that would seem like, okay, done. What's the next point? The next point, though, is you have to prepare, even as you're collecting the statistics, you have to prepare your execs for randomness. So, for example, here is actual measured impact that Jack was seeing at an aggregate level. You notice that up is good. It went up and then it went down. But then later it went up again, but then it went down. So possibly there are other confounding variables, seasonality, competitive forces, other things which are impacting the performance. So what you have to do with your execs is you basically have to give them visual tools, and however they are used to consuming data, a sufficient patience and understanding of the randomness so they can evaluate impact. So here, for example, Jack was saying, here is these dotted lines represent the smooth minimum and maximum that we're seeing, and you'll notice that it's going up in each year. So in this third year, the minimum is equal to what the maximum was on a grid last year. Yes, there are some dots in the third year that are below the high dots in the second year, but on average, overall, we're seeing great improvement. The bands are moving up, and this represents a great impact. So let me just say, okay, you're having this great success. You can see we're into the fourth year here. It's looking really good. So let me ask rhetorically, will success basically avoid the next chasm? Wait, what next chasm? Well, you've gotten to the scale up, but I mentioned there were 5 steps. Here's the 5th step. Okay. The harvest is where the team is rewarded. The team gets credit for the success. They're able to say, okay, we did this. It's now in the hands of people that can support it. Now it's time for us to start new projects. So a chasm can exist where in the acting career, actors many of them hate to be called typecast, where they're basically, oh, you were so great in that role. We want every movie you're ever in for the future to be you playing the same role, the same character. So a lot of times teams are told, you did such a fabulous job here. You made us so much money. I want to chain you to that project, and forever, that's what you're going to be doing. And you might be saying, I'm proud of that work. It's not like I wouldn't do a similar project, but I don't want to basically be told that's the only project you can do, the only type of project. I got into this because I want to do new things and have new impact. So being the harvest means that you're recognized that way. Yes, you are a great multi-talented actor. So Arnold Schwarzenegger, you are this big action hero. Can you also do comedy? So as a data scientist, as an optimizer, wow, you did this big field implementation. Can you also help us over here? So that's what the harvest, that's what success looks like. And one of the reasons why this is a problem is because captured, I think, in this little homily that failure is an orphan, but success has many fathers. And by that we mean or observe that by the 3rd or 4th year at UPS, so many people were involved with the project, and so many people had said, yes, this is wonderful. This is my project. This is part of what I was talking about. That it's sometimes hard to remember, hey, this wouldn't have happened except for this small band of people in the AI optimization group. By the time it's over, it's everyone's win. And sometimes it's hard to get credit for success. It's like you would think, well, don't people remember? No, they just look recently and they say there are hundreds of people involved in this. Yes, you played a key role, but you build little models, and we have a whole group that is responsible for enterprise transformation. It was a big team effort. So that's a good thing, but it's a little bit of a bad thing if you're trying to achieve a harvest. This didn't happen to Jack, by the way. So he did experience a significant, what we would call upside harvest. This is a picture of him standing next to his CEO and the SVP of UPS Global Engineering. He's accepting the 2016 France Edelman Award at Informs, considered by most to be the most prestigious achievement in operations research. They documented and independently verified $300 to $400 million of savings a year. As with all the Edelman winners, this was not a self-published number. This was a number that they put out, but independent judges went in and audited to make sure that these numbers really stood up, which they did. And in addition to the dollar savings, because there were fewer miles driven, which is how a lot of the savings came from. They used less fuel, which is diesel's expensive, but it also had a great green effect. So Jack got his harvest. I'd like to ask or have you guys think about how does the harvest happen at your organization and give you some of our views to wrap up this presentation. First, create this consistent pipeline that doesn't get stuck here. So get a reputation for consistently delivering projects that go from beginning to end that don't get stuck at the pilot phase. I started the talk by talking about the history, and I don't think anyone is on this call that doesn't understand that AI is an explosive attention grabber. And because it's so amazing and so new, people are looking at both sides of it. And I think on the negative side, people are saying, can we trust it? What about hallucinations, mistakes that it's making? And in fact, I think the primary question that people in our world, all of you on this call, all you have to do is figure out how to make this technology that our users will embrace and trust. So what causes AI hallucinations? One major cause would be that they come out of black boxes. So they produce amazing results, but often even its creators can't say where it came from. It's an amazing black box, and that is true of many large language models, but it's not limited to large language models. So as I mentioned, and we strongly believe you have to start not with fancy technology. Oh, we're using such and such an algorithm. We're using large language models. But you want to start by saying, are we getting recommendations that we think are accurate, clear, fast, and robust by whatever's under the hood, but accurate, clear, fast, and robust. In fact, I would like to argue that everyone on this call, you are going to build your AI reputation not by what tools you use or what tools you know how to use. Well, I'm up to speed on the latest innovations that you're reading about in the journals, but you're going to build your AI reputation on trust. You can be assured that if this team is on it, they're going to deliver. They're going to make it work, regardless of what tools they happen to use for each particular step of the program. So what do we mean by work? I'd like to introduce you to what we think is the single most important metric that covers all projects. That metric we like to call time to payback, or TTP as we sometimes call it. So time to payback is the time it takes for a project to break even. So after its launch date, taking into account all benefits and costs, have we completely paid for this project? All the labor costs, any software costs, which are often small, but all the software costs, how long does it take to pay back? I'd like to suggest as a rule of thumb that you should have all of your projects aimed to do a TTP of less than 1 year. So if people are on an annual budget, if they say, I will allocate money for this project from the very beginning to the very end, can you get benefits out of the field? Maybe you're not 100% scaled up, but can you get sufficient scale up, sufficient benefits in production that you've paid for all the costs? And I'd like to argue that a consistently reliable and short TTP will earn you investors. And in a corporation, that would be executive sponsors, investment in increasing your team size. So minimize TTP consistently, and you will be aware. That's the single most important metric I think that teams should be measuring themselves. So a question is, are you measuring time to payback? So that's so much more powerful than return on investment, which is often felt that, well, obviously nothing's going to return on invest in the first year. It's going to take years, and an ROI of 20%. Nonsense. Our stuff can clearly pay for itself if we create the right project and have the energy and enthusiasm and the patience to get it installed and using. We can easily pay, sometimes by 10x, 100x times the investment. And so one of the quick things we want to say is, can we consistently give our investors, our corporate execs, a rapid time to pay back? I want to end with this. So finally, the harvest consists of blending the short and long-term thinking. So I mentioned the short term, which is our job is to take the ball, run with it, get it into the field, and produce a time to pay back. But we also want to blend at the same time, just like the way a lot of optimization routines are multi-objective and are blending short-term greed and longer-term practice. We don't always sell to the highest bidder. We sometimes will favor our long-term or volume customers because they have a long-time value. In the harvest, we're blending short term, like, yes, we're trying to get time to pay back, but at the same time, in the long term, we want to be an employer of choice, want to attract and retain great AI practitioners. If all we're talking about is time to pay back, it could be a burnout shop. It could be just like, quick, get something up. It also might be just get something up that works, good enough, most viable, minimal viable product, quick, 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 agile, agile. And that is often not very satisfying to serious professionals who want to say, hey, I earned the right now to scale this thing up and see how far it can go. It can't always be TTP. So TDP, we'd say, is the single most important metric. It keeps you honest, but I'd say in the longer term, you're also blending. Let's be the employer of choice. Let's attract and retain great AI practitioners. And also at the same time, let's build partnerships with outside AI experts, which feed the team, provide a constant stream of learning and innovation, and also allow you to scale and bring expertise in rather than the school of hard knocks. So all three of these, I think, work together. They're not in competition with each other, but if you bring these three together, I think you'll see your harvest. Anyhow, that is my presentation. Thank you, everyone. I certainly would appreciate hearing from anyone, and I know that we've allocated some space for questions if anyone has, and put them in the chat. So I'd like to turn this back over to my sponsors at Garobi and see if there's any questions that we can answer. Thank you very much.